Hi.
We have a beautiful VF2 right here. And we're gonna show you how we do. Let's get it. The purpose of this project was to design and CNC mill a fixture to hold the IME 144 mill project number 2. Once machined, the fixture was to be tested on these parts. The fixture was designed using Mighty Bite clamps and SolidWorks features. The design was created to address key features, allowing parts to be held and machined with ease. Our design was not created as perfect as desired, but we learned from the mistakes we made. With this design, we created a CAD model and program code to cut this fixture from a blank stock of aluminum. The constraints we were given include a fixture base of a certain size as a tooling plate, a fixture that must mount to the Haas VF2 CNC mill. The fixture must also be able to be indicated parallel or perpendicular to the CNC machine's axes. It must hold both Op1 and Op2 CNC operations simultaneously. It must qualify datums using Op number 1 and locate part off machine datums during Op2. The fixture load and unload time must be under 1 minute, and the clamping forces must withstand the tooling forces using a minimum safety factor of 2. Shown here are our cutting forces calculations. So, we used the 3-2-1 method to ensure safe clamping of our parts. The primary datum was the flat surface of the plate. The secondary datum was the rail placed in the middle of the fixture. Lastly, the tertiary datum was the dowel pins. We incorporated DFM by creating easy ways for the operator to insert the parts, and we made it as easy as possible for the operator. To be sure the fixture was clamped straight, we trammed the fixture. Once we confirmed the straightness, we ran our program to machine parts with the fixture. We created code through HSMWorks and post-processed the code to an NC file, which is readable by a Haas VF2. After cutting the fixture, it was assembled with the standard parts in stock for the initial run of parts. It was at this point we realized the spacing of the Mighty Bite parts for Op number 2 were too far. This rendered the Op 2 side of the fixture unusable. Additionally, we mistakenly drilled for 3/8 inch dowel pins instead of 1/4 inch as was originally designed. Because of this, we were not able to complete any parts, so we had no parts that we were able to test. Overall, this was a great learning experience. While we didn't meet all of the objectives, this project allowed us to exploit the design and manufacturing of a fixture. As stated earlier, there were a few issues with our fixture that prevented us from making parts, including oversized dowel pins, incorrect Mighty Bite sizing for Op 2, and the lack of a notch cut out for Op 2. In addition to fixing the problems with our original fixture, we'd add engravings to clarify where parts are located within the fixture, and we would rearrange the fixture to ensure we did not clamp on the saw cut edges of the parts. Thank you for watching.